Hey everybody, Monaco again. I was wrong. Next note is ionic structure and notation, not isotope structure and notation. So we're going to hit up properties and models of ions, both positive and negatively charged, anions and cations, and how they're represented. So you'll have a Google Classroom assignment to follow it up, and let's hit it. So ionic structure and notation. What exactly is an ion? Well, from our definitions, an atom that has gained or lost an electron is an ion. Okay, so cation formation. Cation formation means that a positive ion is made when an atom loses an electron. And when you lose an electron, it's coming out of that outside ring, so it's going to become smaller. The T for cation looks like a positive charge, so it's kind of easier to remember it that way. Anion, on the other hand, is a negative ion, and it's formed by gaining an electron. And the size of an anion is larger than the atom that formed it, because when you gain an electron, it goes into the outer orbital, the valence shell, and the rest of the electrons spread out a little bit to make room for it, right? It's kind of like when you hop in at the table at lunch and you say, hey guys, move over, I need a little room. It gets a little bit bigger. And an anion, An, stands for a negative ion. So it kind of has a code inside of it for what it is. Ionic charge, nuclear charge, and oxidation state. Well, ionic charge equals the number of protons you got minus the number of electrons you've got. Simple enough there. Ionic charge is equal to the oxidation state of an atom. Okay, so if an ionic charge has a -1, the oxidation state is also a -1. They are synonymous. Nuclear charge is equal to the number of protons. I remember saying this a couple lectures ago. The protons are in the nucleus, and the only thing in the nucleus that has a charge is the proton, so the nuclear charge means secretly the number of protons, which is also the atomic number. So nuclear charge, number of protons, and atomic number really are synonyms of each other. Jeepers, can we make up our minds about which one we're going to use? No, we got to have them all. Polyatomic ion. These are unique, and there's an entire table in our reference tables here, right there, that covers the ones we need to know. Okay? A polyatomic ion is a compound that in itself has a charge. Okay? So, for example, hydronium, H3O plus, means there's 3 hydrogens and 1 oxygen all chemically bonded together, and collectively they've lost an electron, okay, because it's got a positive charge on it there. Okay, so let's just erase that. So we're going to do a lot more with polyatomics in the future, but for now, all you need to know is that poly equals many atoms that make together an ion. And you just need to know that table E is where they all are. So let's do atoms versus ions graphic organizer. Okay? A neutral atom is an atom with the same number of protons and electrons. Number of protons equals the number of electrons. Examples: carbon 12 or carbon. So no charge is indicated in the symbol. An anion is an atom that has gained 1 or more electrons. So it has more electrons than protons now. That's what that inequality means. And so the way we would show this is that another symbol shows up in the corner. Where the selected oxidation states are all listed off the periodic table, you've got another symbol showing up. Okay? And let's see what else we could say. Oh, circled it anyways in the animation. We forgot about that. So the -1 indicates negative charge and having had gained 1 electron. The negative symbol comes from the fact that the electron is negatively charged, thanks to J.J. Thomson. Now, cations. It's an atom that has lost 1 or more electrons. The way we would show this is that protons are greater than electrons. More protons than electrons leaves an overall positive charge imbalance. And again, in the top right corner, you would illustrate that. The +1 indicates positive charge, meaning it lost one electron, and there's +1, one more proton than electrons in this particular ion. Okay. Your Google Classroom assignment is to follow. After you finish your notes, go and check on your Google Classroom portion of the homework, and come to class ready to go over a few practice pages in this atomic theory packet. Thank you so much for watching. See you in class.